Alright, so let's get started. Today we are going to discuss about Quicksort. Um, and this we will be understanding the theoretical part of Quicksort, how Quicksort work, what is the basic ideology, what's the main uh, point, or what's the main criteria in Quicksort. So let's get started. So Quicksort, like merge sort, is based on divide and conquer algorithm. It's based on divide and conquer ideology. Firstly, we will be dividing the array, then we will be applying some rules or some ideology to sort that array, and it's a recursive algorithm. We must understand recursion before getting on with this algorithm. So what's the main ideology in Quicksort is that we choose a pivot element, and based on that pivot element we have to partition the array into two parts. Um, and the other condition is that elements to the right of the pivot are always greater than the pivot element, and elements to the left of pivot are always the small elements or elements that are less than the pivot element. We will look up uh, at an example in few minutes. Firstly, let's understand the theory. So choosing that pivot element and partitioning the array is repeated for the left array and for the right array, and eventually we will be having every element as a pivot element. So if every element to the left of the pivot is smaller than pivot, and if every element to the right of pivot is greater than pivot, so what does that implies is that the pivot element is at its sorted right order. The pivot elements is at its position. So every element will be a pivot element and will be at its correct position at the end of this implementation of Quicksort. And the basic difference between merge sort and Quicksort is that in merge sort, we used to partition the array, we used to divide the array, and when we used to combine the result, the sorted array, we use different external arrays to store those partition elements. We use external arrays. So Quicksort is a in-place algorithm. We will not be using any external arrays, and the time complexity of Quicksort is big of log base 2n, which is very much similar to merge sort. And the n log n complexity, time complexity of Quicksort is of average case. It is possible that at worst case the time complexity can be order of n square, but that's very rare that we will be having order of n square time complexity. The average case is we will be having the time complexity of n log n. So next, to understand this better, let's take up an example. I have chosen the example, I have seen this example on Stack Overflow, and let's understand with the help of this example. We have an array given to us. So there are many implementation of Quicksort. We can use we can choose any element as a pivot element, but the implementation that I'll be showing you, in that implementation or in that explanation, I'll be using first element as the pivot element, that is 15. So 15 is our pivot element, as you can see, and now we will hold two pointers. One is at 15, the other one is to the uh, end of the array or at the last index of the array, and we'll compare these two, and as 15 is less than the element to its right, so we are good. We do not need to swap these two elements. In that case, we will decrement our pointer that's pointing to the right side of the array or to the last index of the array. Now we will be comparing 15 with 11. Now 11 is smaller than 15. We have to swap. Here we have swapped the array elements 11 and 15. Now the pointer will move forward to 9 and 11 is compared with 9. As 9 is smaller than 11, 9 will be swapped with 11. Now the pointer is decremented. 13 is compared with 9. We are good because 13 is greater than 9. We will move forward. Now the pointer is decremented. We have 27 and 27 is again greater than 9. We are good. We can move forward. We can decrement our pointer. And 41 is again greater than 9. 34 is greater than 9 and 19 is greater than 9. So this completes our first iteration. Now we will go on and increment our pivot element. We'll choose 19 as a pivot element. We'll start the other pointer from the end index of our array. We'll keep on comparing, and yeah, at the end we will have a sorted array. So the first element or the pivot element that we had was 15. We can see at the end that all the elements to the no, we have pivot element as our first element that was at the index 0, and we can see that all the elements that could have been smaller than 9, but there are no elements that are smaller than 9, so there is no element present on the left side, but the elements that are greater than 9 are on the right side. So this completes our first iteration. In that way, each and every element will be sorted. In the next iteration, the pivot will be considered the second or the first index, second element of the array, and we'll keep on moving forward. And yeah, this is about the quicksort implementation.